Hello and welcome to another one of these ADD videos. Today we're going to be looking at how to solve first order differential equations part 2 of the substitution methods. We're going to be looking at Bernoulli's equations. And these are rather distinct in the fact that you should be able to recognize them. They will have a y to the n next to your q of x over here if it's in this general form. And to me, it's easier if I recognize Bernoulli, or I'm just trying different methods. I would divide both sides by y to the n to see if it's a Bernoulli. The reason why I do that is it makes it a lot simpler to recognize. When I have this form right here, I know immediately that this term right here, whatever's attached to my p of x, that's going to be my z value. That's what I'm going to equal z. All right? So, again, I'm going to divide both sides by y to the n, and there's an assumed 1 right there, so y to the 1 divided by y to the n is y to the 1 minus n. And then there's no y term in the beginning, so it's y to the negative n. And now immediately I know that whatever this is, that's going to be my z. If you've done it properly, the derivative of whatever your z term is right here should be what you have right here. You might have a coefficient or something like that that you can divide away, just like any other substitution you've done up until now. But the exponents should match up. The derivative of this term should be whatever this exponent is. Let's see a general example. If I had this form, doesn't matter what p of x and q of x are, I'm not going to solve this problem. I look here and I see some function y and then some function y cubed. If I divide both sides by y cubed, this is what I would get. I should be able to recognize this as a Bernoulli equation with z equaling that y to the negative 2, because it's whatever's attached to your p of x. And then at that point I can derive this to get what dz dx is, and you can see that here y to the negative 3 is what I have in front of my dy dx. This negative 2 can be divided over here and substituted in for the dy dx term. So y to the negative 3 dy dx is what I want. So I would have a negative 1/2 dz dx in place of that in my equation right here. And this would become p of x times z instead of y to the negative 2. And then you can just solve, if you've done your substitution correctly, it's either going to be a separable equation, or you get the z's on one side and the x's on the other side and then integrate, or one of those integrating factor techniques we've already covered. All right? You can see all this is foundational. Make sure you're pretty good at your integration skills before you delve into all this differential equation stuff. Alright, so I hope I've clarified any confusion or any doubts that you might have about Bernoulli's equations. Make sure that you practice these problems. They might seem pretty straightforward, but get a few under your belt before you feel confident, before you can say I can take a quiz or a test. Alright? It's better to overstudy than understudy. Thanks for watching. Have a nice day.